Okay, so for our first video, I'll be going over how to solve a basic Thevenin equivalent circuit. I drew this random circuit I came up with here. It's pretty simple. It's got a couple components for you to look at. And just really simple question. You might see this in whatever you're doing. It might look a little bit different. You might have an A and a B here. But what you'll have essentially is a circuit. It's very simple with two ports. Now, however, what we're looking to do is to take this circuit and we're going to try to turn it into something simpler. So it's Thevenin. So we're going to have a Thevenin voltage source with VTH, and we're going to have a resistor named RTH. And we have these 2 points here. So what I'm trying to do is take this whole complex circuit and turn it into this simple little model here. So the first step to this sort of problem is we need these 2 parameters, RTH and VTH. RTH is generally easier to solve, so we'll start with that. Find RTH. Now, how do we find RTH? So we have to terminate all the sources. So in this circuit we have here, we have a single current source. So what we're going to do is turn that into an open circuit. So I'm going to redraw my circuit now. So I'll have all the resistors will still remain. So I'll still have my 2 ohm. I'll drop the ohms just to make things easier to read. We have the open circuit. We still have the 2 ohms here. We still have the 4 ohm resistor there. And now we come to the 2 terminals. Now from this point, we want the resistance or the equivalent resistance looking into this simplified circuit. So how do we solve that? This is just basic resistor simplification. So first look at how we can, the easiest simplification you can do, and we'll start with that. So we have these 2 resistors here, the 2 and the 2. You can easily see that these are parallel because they both are connected to the same nodes. So I'll just circle these in orange. All right, parallel. So for the parallel resistors, it's 2 parallel to 2, which using the shortcut equation, 2 times 2 over 2 plus 2, you do the math, 4 over 4, 1. So now I'm going to redraw my circuit, except with the simplification now. So those 2 resistors here, they combine into a single 1 ohm resistor. Now I still have my 4 on top there and the 2 terminals. And I still am looking in. Now this is a pretty easy simplification step. You can see that the 2 resistors are connected one after the other with nothing branching off in the middle. So these are in series. Therefore, we could just add them. Now 1 plus 4 is 5. Redrawing the circuit once again. This step you don't have to do if you realize how this problem is being solved now. So you have a 5 ohm resistor. Well, your equivalent resistance is 5 ohms. Therefore, you just found the Thevenin resistance, 5 ohms. So, going back to the top of the problem, we found the first value. Now, the second part of a Thevenin problem is to find the other value. In this case, the V Thevenin. So, I'm going to go back down to my paper, start another series of steps. I'll call this find V Thevenin. Now, how we find V Thevenin? We take the original circuit we have and we open circuit the 2 terminals. In this case, it's already open circuited, but maybe in a problem you might have something connected here. So in our case here, I'm just going to redraw the circuit with all the components. And don't be afraid to redraw the circuit in whatever problem you're doing. Just at least copy the values down right and try not to forget some components. So finding VTH, VTH is the output voltage here. or it's a voltage across the two terminals. Now in this circuit, there's one current source, a couple resistors, so pretty simple. I'll just use some circuit analysis to solve this. No mesh or nodal analysis here. To begin with, this 4 ohm resistor is open circuit on one side, so no current flows through this. I can get rid of it. And another easy simplification, I have these two 2 ohm resistors. Now both top sides of them connect to the same node, and the bottom, they both connect to the same node. Therefore, they're in parallel. Forget about, or just leave the current source in the middle. It doesn't matter. Once again, for the parallel resistors, 2 is parallel to 2, which is equal to 2 times 2 over 2 plus 2, using the shortcut equation, equals 4 over 4 equals 1. Or you could just use the logic above, because we already solved it up here. So, using this, these two 2 ohm resistors combine just into a single 1 ohm resistor. I still have my current source. Now, because I got rid of the 4 ohm resistor, because it's open circuit on one side, my terminals have moved, and the VTH is now just the top of the circuit minus the bottom of the circuit. I can solve this using Ohm's law, because if I realize this is just the voltage across the resistor. And in this circuit, there's a current source, and then I have a loop. Remembering from Ohm's law, V equals IR. VTH is equal to the 12 amp current source times the 1 ohm current or resistor equals 12 volts. So we found VTH and we found RTH. Now what you have to do, find the Thevenin equivalent circuit. We should draw the Thevenin equivalent circuit. So take the voltage source, VTH, and the resistor, RTH. This is just the standard shape. All Thevenin equivalent circuits should look like this. And RTH is equal to 5 ohms, as we found earlier in the problem. VTH equals 12 volts. Remember your units. And this is a final solution for the problem. I'm going to put a nice box there, and there you go. I have now solved a simple Thevenin equivalent circuit. Let me know in the comments what problems you want me to solve next, and any feedback on the video. This is the first one, so I can change things as we go along. All right, have a good one.